to start with Newton's laws of motion. We have to start with the forces. So let's consider the types of with examples. The very basic force we must remember always when we deal with laws of motion is the weight of the body. So that is weight mg, that is mass into gravity. And many times we face questions based on normal forces, that is capital N, tension force T. So when we normally come across weight, so for example, whenever we have a question based on blocks or a person, then we need to deal with weight when surfaces are involved. Tension force when strings are involved. So let's talk about force in general. Force is an interaction between two particles or objects or surfaces. The force can be pull or push. Suppose two objects A and B are there and they are pulling each other. So how to represent the forces? So A is pulling B, so the direction of force on B will be towards A, and direction of force on A due to B will be towards B. So we can represent these forces as force on A due to B and force on B due to A. Suppose A and B are fixed, then the forces tends to bring them closer. But suppose A and B are free to move, so they will start moving towards each other. For example, the two objects are placed on the smooth surface, so the two objects will attract each other and they will be pulled towards each other. And when the two objects push each other, suppose A and B are two objects, they are pushing each other, so the force on A due to B will be away from B and force on B due to A will be away from A. So let's call these forces FAB and FBA. Suppose the A and B are free to move, they will repel each other, they will move away from each other if they are free to move. And if they are not free to move, they have the tendency to move away from each other. For example, we consider two objects A and B. They will push each other or pull each other. We can call it action reaction forces also. These forces are action and reaction forces. For example, when we talk about pull force, FAB as action force, FBA will be reaction force. It could be the other way also. You can call FBA as action and FAB as reaction. And similarly, when we have a push force, when A and B are pushing each other, any one of them can be called as action. So suppose FAB is action, then FBA will be reaction, and FAB is reaction, then FBA will be action. Any force will be action, other will be reaction. There is a surface and there is a block kept on it. Block A is interacting with this surface. The surface could be smooth or rough. Considering smooth surface, the block A is experiencing force which is called as normal force N. And what about the surface? So surface is also experiencing normal force. This is the force on block due to surface, means surface is exerting this force on the block, that is a push force, and the surface is also experiencing equal and opposite force, so that is force on surface due to block. These are push forces and they are action reaction. If I am saying this normal force on the block due to surface is action, so the normal force on the surface due to block A is reaction. Let's consider a case in which a block is interacting with a string. This is the block A and it is connected with a string. The other end of the string is fixed with the ceiling. Now here we have three objects: ceiling, string and the block. String is pulling the ceiling. Force on ceiling will be down. Force on ceiling is downward. And the ceiling is pulling string up. So force on string is up due to ceiling. And similarly, when we talk about string and block, so string is pulling the block up, so this is the force on block due to ceiling. Similarly, we consider force on block due to string, so force on block due to string is upward, and the force on string due to block. So what about a force on ceiling due to block? Is there any force? So answer is no. The block and the ceiling are not interacting with each other. Ceiling is interacting with a string and the string is interacting with block. Now what is a tension force here then? Tension force is a force exerted by a string on any object it is connected with. So we have seen how a block is interacting with normal force and how a block is interacting with tension force. Now let's talk about the direction of normal force and tension force. So let's go back to the diagrams. So when we drawn the diagram for block kept on horizontal smooth surface, so as you can see, the normal is acting upwards. So direction of normal is perpendicular to surface and it is a push force. Direction of tension force, it acts along string. It is a pull force. So as we have seen, when the string is connected with a block, the string is pulling the block upward because the string is vertical. Let's draw a few more diagrams. Suppose the surface is horizontal and the block is kept on it, and there is a string connected to the block. The mass of the block is m. Now let's draw tension force and the normal force. So the tension force acting on the block is along the string, and it is a pull force. So string is pulling the block towards itself. So tension force is rightward. The surface is below the block, so the normal force is upward, and the weight mg is downward. So this is the free body diagram for this present situation. What if the string is inclined and the surface is horizontal and the block is kept on the surface? Suppose the string is making angle theta with horizontal. Now let's draw the forces. So the tension force will be along the string. Normal force is perpendicular to surface. Weight mg is vertically downward. And this dotted line is representing horizontal direction. Tension T is making angle theta with horizontal. We can break tension into two components, one along the surface. So this will be T cos theta, and one perpendicular to surface, T sin theta. Normal is as shown previously. Mg is acting downward. So what could happen to this block when the string is connected to it? So if there is a tension in the string, so the block will be pulled along the string if there is no resistive force, or if the block is free to move. So in both these cases the block will accelerate. We will discuss that Newton's second law later. Currently we will stick with equilibrium of forces. Now let's discuss Newton's first law. In this topic we will learn about balanced forces, equilibrium of forces. So the statement for this Newton's first law is a body continues its state of rest or of uniform motion when net external unbalanced force is zero. That means forces must be balanced to apply Newton's first law. When we talk about balanced forces, there will be minimum of two forces. For example, 1 Newton is acting left and 1 Newton is acting right, then the forces are balanced. It could be three forces, like 1 Newton left, another 2 Newton left, and 3 Newton acting rightward. That is also balanced forces. It could be three forces at some angle. So for example, 1 Newton, another 1 Newton acting at 120 degree, and third 1 Newton is acting at again 120 degree with the previous 1 Newton. So resultant of these three forces is also zero. So these three forces are also called as balanced forces. Let's do some questions based on NEET exam and based on balanced forces. So that is known as equilibrium of forces. Now the question is, find normal force acting on the block. The horizontal surface and the block is kept on it. So let's draw the free body diagram. Force mg is acting downward. Normal force n is acting upward. So you can write n is equal to mg. Why? Because the block is not moving at all. It is kept on surface. The forces are balanced. Next example. Suppose the block is kept on surface and external force of F Newton is acting on the block downward. The surface is horizontal, so force mg is acting downward, normal is acting upward, external force F is acting downward. So the forces are balanced, so we can say n is equal to mg plus F. Next, a horizontal surface is there and the block of mass m is kept on it. Force F is acting upward, mg acts downward, force F upward, normal also upward. So we will write F plus n is equal to mg. So n is equal to mg minus F. Suppose there is a ceiling and a string is connected with it. The other end of the string is fixed with a block. So on the block, tension T acts upward, weight mg acts downward. So T is equal to mg. Tension on the string is mg. There is a horizontal ceiling and a string which is inclined connected with a ceiling. The other end of the string is fixed with a block and the block is pulled rightward with a force F. The string makes angle theta with vertical. Let's draw free body diagram for the block. So force, external force is rightward, tension T along the string, mg downward. The string is making angle theta with vertical. Now let's take component of tension. T sine theta horizontal, T cos theta vertical, external force F rightward, mg downward. Now since the block is at rest, it's in equilibrium, so the forces are balanced. So we can write F is equal to T sine theta and mg is equal to T cos theta. Let's name these equations as first and second. So to find relation between F and mg and theta, we can divide 1 by 2. Divide 1 by 2 to get relation between F, mg and theta. So F by mg is equal to sine theta by cos theta, and that is equal to tan theta. So F is equal to mg tan theta. So if in a question theta is given, mass is given, so we can find force. How to find tension? Sine theta from the equation is F by T, cos theta from the equation is mg by T. Now if we square and add these two, so we know that sine square theta plus cos square theta is 1. F by T whole square, F by T square plus mg by T square is equal to 1. So F square plus m square g square is T square. T is square root of F square plus m square g square. That's our answer.